Hello and welcome. I'm Phil Jersa, Cloud Solution Architect at Microsoft. Joining me today are two other members from my team, Joe Karasha and MJ Shaney. In this video, we will present a technical overview of our Nextflow on Azure solution. Nextflow on Azure is an open-source starter kit solution built by the Emerging Opportunities team. Our goal is to demonstrate running on-demand Nextflow workflows using Azure. Before we get into the technical overview, let's hear a little more about Nextflow from Joe.
So what is Nextflow? Nextflow is a workflow manager that was developed to simplify the process of building and running bioinformatic pipelines. Bioinformatic pipelines are usually very complex with many distinct steps, with each step potentially running a specialized tool or specialized process. The steps are usually dependent, and output from one step can be used as input into a secondary step. Nextflow separates the workflow definition from its execution, which makes it possible for you to define your workflow in one environment and to run it in different environments, whether you're running this locally on your VM or your desktop, running it on your local on-prem compute cluster, or running this on the cloud. The benefit of running this on Azure and running this on the cloud is it gives you maximum scalability. That allows you to basically run Nextflow with a lot of compute that's readily available. You can choose different compute types that you want running on Azure Batch, so you can scale up and scale down your pipelines, your workflows as soon as they're completed. This allows you to save time and to save money because when the workflow is complete, you basically turn off the compute and you don't have to pay for any of those resources. This also allows you to use Azure Storage, which gives you unlimited scalability. You can have all your data, petabyte level scalability, which will allow you to handle not just tens or hundreds of samples, but even thousands of samples that you might already have on-prem.
Thanks, Joe, for that overview. Nextflow is indeed a powerful data processing workflow tool. As we just learned, Nextflow separates your workflow definition from the processing. It uses a component called an executor to configure the compute platform used for pipeline execution. One of these built-in executors is Azure Batch. So far, everything we've discussed could be set up and run from a local workstation running on Linux. The value of our Nextflow on Azure solution is that it presents a web interface from which a user can select an available workflow, specify a few parameters, and run the entire process remotely using on-demand Azure container instances. This removes the requirement to install any tooling and kick off jobs from a local workstation. Running Nextflow on Azure offers several other benefits as well. Azure can provide significantly better performance and scalability compared to running on a local workstation. Running on demand with Azure Container Instances and Azure Batch provides cost flexibility. You only pay for compute when you need it. Your data and results are stored securely on Azure Storage, which is highly dependable with built-in loss prevention strategies. Here is the solution architecture diagram. First, we have a web application written in C# Blazor WebAssembly hosted on an Azure Static Web App as our user interface. A backend .NET 6 minimal web API and database are implemented using an Azure App Service and Azure SQL. A durable Azure function orchestrates our on-demand Azure container instances. While the Nextflow process is running, telemetry is sent to a weblog endpoint implemented with an HTTP-triggered Azure function. The input data and result files are stored using Azure Blob Storage. Now let's see our solution in action. I'll browse to the site and navigate to Pipelines. Then I'll select the ATAC SEQ pipeline and click Execute. Next, I need to give the job a name and fill in the required input parameters. Finally, I can submit the job by clicking Execute. Once submitted, I switch to the status page where we can monitor the completion status of our job. While we wait for our job to complete, let's switch over to Azure to see what's happening behind the scenes. After a few moments, I can refresh the page and we'll see a new Azure Container Instances resource. This is our on-demand Nextflow job. By drilling into the details, we can see that a new container is spinning up. Once ready, I refresh the Logs tab where we'll see console output from the Nextflow job. Next, let's hop into our Azure Batch account. Switching over to the Jobs tab, we'll see a list of the individual task processes coming from our Nextflow job. For more information about our compute lifecycle automation process using Azure Functions, here's MJ Shaney.
I will be talking about the use of Azure Functions in our backend. What is their purpose, and why did we choose to use Azure Functions to accomplish that purpose? As previously mentioned, we are decided on moving away from VMs and to use on-demand computing with containers. Since Nextflow pipelines have a longer life than an API request, we needed to offload management of the lifecycle of our Nextflow containers to another service that could match the life of these containers. We also wanted to be able to trigger this lifecycle from the API. Keeping these requirements in mind, we could choose Logic Apps or Azure Functions, either of which would allow us to build a workflow that could create the container or Nextflow to execute on and destroy the container once it completed its work. Logic Apps and Azure Functions are both serverless compute services that share similar connectors to other services and provide HTTP request triggers. The advantage we saw in Azure Functions over Logic Apps was primarily our ability to write infrastructure as code and automate creation of the function app using a bicep template. Furthermore, it allowed us to keep our application logic in the same solution. Our Azure function code is written with C#, which means that a developer writing C# in our Blazor frontend or C# in our minimal API backend could just as easily get started working in our functions project. Taking a look in our Azure function workflow, we use 5 different Azure functions. Listed in order of execution, we have HTTP start, container manager orchestrator, container manager create container, weblog tracer, and container manager destroy container. Of these functions, 2 of them are triggered by HTTP requests. One of them is a durable function, and 2 more are activity triggered functions that are orchestrated by the durable function. The first thing that happens is that a user makes a request to our API, which will in turn trigger the HTTP start function through a post containing data about our desired Nextflow pipeline run. The HTTP start is an HTTP triggered function whose sole purpose is to trigger the orchestrator, which is a durable function and thus must be triggered by another function using a durable orchestration context class. Durable functions are special stateful functions that are longer lived and used solely to orchestrate other functions. The orchestrator will trigger the activity function create container, which will use the management SDKs to spin up a container group and container based on our unique run name in the request provided to the HTTP start function from the APIs. Once the create container completes, it passes the container group ID back to the orchestrator, which will wait for either A, 48 hours to pass, or B, for an event fired from the weblog tracer. The weblog tracer function is another HTTP triggered function. We provide the URL to this function with the with weblog option in our Nextflow command as given by the API. This causes Nextflow to send requests from the container to the weblog tracer with events about the progress of the Nextflow run in the request payload. The weblog tracer receives these events and saves the status to our database. When it receives the completion event for the entire Nextflow process, it uses a durable orchestration context to trigger the event that the orchestrator function is listening for. After receiving that event, or after 48 hours has passed, whichever comes first, the orchestrator will send a command to destroy the container group containing our Nextflow container by triggering the destroy container function. Once that is complete, our orchestrator instance ends and the lifecycle of our Azure Functions, along with the container they manage, is complete.
Thanks, MJ, and thanks to all the viewers. I hope you've enjoyed this overview of our Nextflow on Azure solution. Here are some useful links to help you find our solution on GitHub and learn more about Nextflow.